All right, everyone. Today I want to talk about the loanable funds model. And this is basically going to be a supply and demand diagram that explains the equilibrium interest rate, investment, and level of savings in the economy. So in that sense, it's going to be very familiar in the sense that it's a supply and demand diagram that you've learned in microeconomics classes. So it's really just a particular application of that type of model. But there's some specifics that we really have to hit hard so you understand what exactly do we mean by price and what quantity demand and quantity supplied are going to be in this model. And then we're going to use the model to talk about the way we think budget deficits will affect the economy, right? So that's what I really want you to get out of this. All right, so before we actually go ahead and get into this, I want to just do some brief introductory stuff. So we'll call this one introduction. And I just want to do some of the basic national income accounting that lies behind the model. So let me just first start off, and we'll call it brief national income accounting. Brief national income accounting. Okay. Now, what I want to do is just talk about what exactly investment and national savings are going to be, and then try to demonstrate to you that as a matter of national income accounting, they have to be equal. And then we'll talk about a model that makes them equal in equilibrium. All right, so let's talk about investment first. So one will be investment. Right. So I just want to start off by reminding you of that national income identity we've worked with already, which basically just says real GDP, remember, is Y, is equal to household consumption plus investment expenditures plus government expenditures on goods and services and net exports. And here it's going to be important to remember what we mean by investment. So remember, I'm an economist. This is not a finance class. I'm not talking about financial investments. I'm not talking about the purchase of stocks or bonds or anything like that. I'm talking about the purchase of physical assets. So there's really three types of physical assets. You remember, there's residential housing, so new residential construction, that's part of investment expenditures. Inventory investment, that's another investment expenditure. But by far the largest and most important, especially for the applications we're worrying about now, is investment by firms in new plant and equipment. So that's factories, machines, robots, tools, basically anything that's used to produce other goods and services. Okay? So that's the basic national income identity, if you might remember from before. We're going to go ahead and simplify this one bit. And we're going to simplify it by assuming that net exports equal zero. And the reason why we want to assume that net exports equal zero, because this has the effect of saying, hey, all the borrowing that we're talking about in this loanable funds model, it's done within the domestic economy. So if you think about the United States, that means all borrowing and lending that's being done is being done within the United States. So that essentially assumes the U.S. government doesn't borrow from China or Britain or Japan, which is not realistic, but it turns out it does, if you relax that assumption, you get basically the same results. So for our first pass at the model, I'm just going to go ahead and make that assumption. So if you go ahead and say net exports equal to zero, then this is going to go ahead and simplify down to real GDP is consumption plus investment plus government expenditures. All right. Well, I just want to go over here. I'm just going to manipulate that a little bit and say, well, I'm just going to go ahead and take consumption and government expenditures over to the left-hand side of the equation, and actually I'm going to take, I'll go ahead and do it that way, and you get real GDP minus consumption minus government expenditures equals investment. And I'm used to writing, if investment's what I care about, I'm used to writing it on the left-hand side of the equation, so I'm just going to go ahead and rewrite that. It says investment is real GDP minus consumption minus government expenditures. So what that means is if you think about all the goods and services that are produced in the economy, then whatever gets consumed by households and whatever gets consumed by the government on goods and services is not available for investment. So really the amount of investment that happens in the economy is all the goods and services that are produced in the economy that are left over after households and the government consume. So whatever is not consumed by the households and the government is left over and available for investment expenditures. So that's the way I want you to think of investment for right now. It's just real GDP minus household consumption minus government expenditures. All right, so think of that as investment. And this is roughly going to be the demand side of the loanable funds model. Right? So it's going to be households and firms who borrow to finance investment expenditures are going to be on the demand side. So now let's talk a little bit about the supply side, which is going to be a little bit more national income accounting. So I'll call 2 national savings. And I'll just go ahead and erase all this. And we'll have 2, national savings, which I'm going to go ahead and abbreviate as an S. Now, there's going to be basically 2 types of national savings. So national savings as a whole is going to be S, but it's going to have 2 components. It's going to have savings by private citizens like you and me, by households and corporations. We're all going to call that private savings. So I'll just label that as an S with a private in the subscript to let you know it's private savings. Plus, we're going to go ahead and add government savings to that. So that's savings by state, local, and federal governments. Okay. So what are these 2 components? Well, we'll do government savings first. So government savings is just going to be equal to the entire amount of tax revenue that the government brings in. So you can think of almost tax revenue as the government's income. It's not really, but for our purposes right now, we'll go ahead and call it that. So it's all the tax revenue the government takes in minus everything they spend it on. And remember, the government has basically 2 types of expenditures. It has expenditures on goods and services, that G term that I just erased. But the government also spends money on transfer programs. Remember, these, and if you wanted to, you could even write it like this. Okay? Now, remember, transfer programs are expenditures on things like unemployment benefits, welfare, Social Security, where the government is making a payment, but it doesn't get a good or service in exchange. It's simply transferring income from one group of households, taxpayers, and taking that income and transferring it to another group of households, meaning the elderly or those people on welfare or those households that are unemployed. So it's a pure transfer. The government gets no good or service in exchange for it. Now, if this term is greater than 0, then that means tax revenues are greater than total government spending. The government runs a budget surplus. And if this number is less than 0, taxes are less than total government spending, the government's running a budget deficit. And we'll come back and talk more about that later on. Private savings is just going to equal all the income that goes to households, right? Because households get income, but they also get transfer payments from the government. So it's going to equal income plus transfer payments, right? Now, households don't get to decide what to do with all of their income. If you think about your paychecks, you have the gross pay, which is on the top part of the paycheck, and then net pay at the bottom of the paycheck. That's what actually gets deposited in your bank account. The stuff in between, that's taxes. So the government takes a chunk of your paycheck every month in the form of taxes. And we'll just write it as capital T for taxes. And this is going to represent both income taxes at the state, local, and federal level, those FICA taxes, which are your Social Security taxes, et cetera. And so it's going to be, private savings is going to be income plus transfer payments minus taxes. That's disposable income. You might remember what we called it before, minus consumption expenditures. Okay? All right. Well, if that's the case, then I'm just going to go ahead and rewrite national savings as it's private savings. So I'll go ahead and write that first. Income plus transfer payments minus taxes minus consumption expenditures plus government savings. And I'll go ahead and write that next. And that'll be tax revenue minus government expenditures plus transfer payments. All right. Now, it's a whole bunch of algebra there, but I just want to go ahead and make a couple of steps. First, I'm just going to get rid of these parentheses that are inside the brackets because they're actually cluttering things up, and it obscures one important point. So I'm just going to write this as income plus transfer payments minus taxes minus consumption. So all I did is get rid of those parentheses. And then in here, I'm also going to get rid of the parentheses. Got to remember to distribute that negative sign, and I get this. All right. So now I want to do some cancellation because I've got positive transfer payments and negative transfer payments. So let's just get rid of those to make life a little bit easier. And we've also got taxes in there as a positive and negative. So let's just go ahead and get rid of those. That makes life a little bit easier. And I'll go ahead and just write the result over here. We're going to get national savings is going to be equal to the total amount of income generated in the economy minus the amount of consumption by households minus the amount of consumption by the government. All right. So the total amount of national savings is just going to be real GDP minus consumption minus government expenditures. All right. So that's the second point. And now I'll make my third point, and I think you might be able to see if you take a look back at what the equation was for investment. So we'll just go ahead and call this 3 in my outline. I'll go ahead and leave that up there, that last equation. And the key point here is what we're going to have is if I write down investment, that's income minus consumption minus government expenditures. If I write down national savings, it's the same thing. That means by just given the way we've defined the terms, investment has got to be equal to national savings. Okay? Now, I haven't done anything in terms of talked about a model to explain why this is going to be the case. This is just purely by the definition of how we've defined investment that this is going to end up being the case. So what I want to do right now is if we think about this is the demand for loanable funds, And this is our supply of loanable funds, Right? What we want to talk about next is actually talk about the model that shows how the real interest rate is going to adjust to make sure that investment is always going to be equal to savings. So we'll call that B in our outline. So let me erase all this. And as I said, it's going to be a supply and demand diagram. So what we want to go ahead and do is, it's going to be a supply and demand diagram. So what we want to go ahead and do is talk about the demand side and talk about the supply side. So actually, let me just go ahead and call this Roman numeral 2. So it won't be the neatest outline in the world, but at least it'll be a little bit cleaner. Loanable funds model. Right. So what I'm going to do is I'm going to first talk about the demand side, then we'll go ahead and talk about the supply side. So the demand side of the model, which means we're going to be talking about investment. And we're going to keep the model real simple because we don't actually need a ton of complexity to get to the points that we need to talk about later on about government budget deficits and things that affect, or the major things that drive interest rates in the economy. So what we're just going to go ahead and do is just, for simplicity, say, you know what, there's basically, as far as private citizens go out there, there's two groups of people who are borrowing. Households borrow and firms borrow. Households borrow to finance investment. And the investment activity that households engage in is the purchase of new residential construction. And firms are also going to borrow to finance new plant and equipment. Now, the key thing here is what's going to be the quote-unquote price of borrowing. And for us, that's going to be R, the real interest rate. Call that the real interest rate. And it's going to be the quote-unquote price of loanable funds. In the following sense, it's the cost of going to the bank, to borrow. And here's the basic idea. If the real interest rate was 0%, then basically it'd be very cheap for people to go to the bank to borrow. So we've talked before about how the real interest rate is the cost of borrowing funds. So if the real interest rate was 0%, it'd be quite cheap to actually go ahead and borrow. So a lot of people would do it. On the other hand, if the real interest rate were to rise from 0 to 1 to 2 to 3 to 4 to 5 to 10%, it's progressively getting more and more costly for households to go ahead and borrow. So some of them will cut back on borrowing. Same thing's true of firms. As real interest rates go up, it becomes more costly for firms to go ahead and borrow to finance new investment projects. So few of them are going to go ahead and do it. So we can go ahead and think of investment is just some function of the real interest rate, where I here stands for function. So it's the level of investment is just some function of the real interest rate. And more importantly, it's going to be a negative function, meaning, and let's do all this as 1, meaning as you increase the real interest rate, you're going to end up decreasing the level of investment. So what does that mean from our perspective? So let's just talk about the derivation of this investment demand curve. All right. So I'm just going to go ahead and draw a nice, simple diagram. We're going to put the real interest rate on the vertical axis, or just have R as the real interest rate. We're going to put the level of investment, I, on the horizontal axis. And I just need a point at random to go ahead and have a reference point. So I'm just going to go ahead and say, what if? Right? And I'm not worried about y right now. I'm just going to say, what if that's the real interest rate R1? Then I'm just going to go ahead and say, for the sake of argument, we'll be at a point like A here. And at point A, this is the level of investment expenditures. Okay? Now, suppose for the sake of argument that there is a decrease in the real interest rate. I don't care why. We don't have a full supply and demand diagram yet, so I can't give you an explanation of why, but we'll go ahead and get to that. If there's a decrease in the real interest rate, so it becomes less costly for households to go out and borrow to finance the purchase of new housing, and it becomes less expensive for firms to go ahead and finance the purchase of new capital goods, then firms and households are going to want to borrow more, meaning they're going to want to go ahead and invest more. How much more? I don't actually know, because we're not at that level of detail. I'm just at qualitative results. So I'll just go ahead and say, for the sake of argument, if the real interest rate falls down to here, oh, I don't know, we'll say the level of investment goes up to I2. Okay? Now, for us, that means you're going to be at point B in the diagram. For us, 2 points are going to go ahead and determine a line, so I'm just going to go ahead and connect those 2 points. Hopefully I can draw this as basically a straight line. Oh, not really, but I'll go ahead and make the dots larger and call this the investment demand curve. All right. So there's our investment demand curve. It's downward sloping in the real interest rate. As the real interest rate increases, the quantity of investment demanded, or the real interest rate decreases, the quantity of investment demanded increases. And as the real interest rate increases, the quantity of investment demand decreases. Okay. So that's the derivation of the curve. And if you remember from microeconomics, not only do you want to derive the curve and figure out what the shape is, but you actually want to understand what's the thought experiment that you conduct when you go ahead and draw the curve, so you can figure out what are the things that are going to end up shifting the curve around. So if 2 is derivation, 3 is going to be shifting the curve. So let's just go ahead and do 3. Shifting the curve. And there's actually a whole host of things that might shift the curve around. What I'm going to do is just do 1 or 2 examples to try to give you a flavor of what the thought experiment you ought to be conducting in your mind to try to figure out what's going on here. So pay as much attention to just the general principles as well as the specifics. So to be able to do that, I'm actually going to need another investment demand curve. So I'm just going to go ahead and put that over here. And we'll call this, and instead of writing investment demand, because that gets kind of tedious, I'll just go ahead and write I. And since this is going to be our first investment demand curve, I'm going to write it as I1. And I need a point as a reference point again. So I'm just going to go ahead and call this R and say that's my the real interest rate. And through all these examples, I'm going to go ahead and keep the real interest rate fixed at R. And I'll extend it over here to my investment demand curve. Here's my point A. And down here is the level of investment. Okay? And so point A is going to be my reference point. And after every event I just described, I'm going to ask you, do you think the amount of investment that occurs in the economy is going to increase, or the amount of investment is going to decrease? And based upon that, we're going to go ahead and figure out whether the investment demand curve goes ahead and shifts to the right, or whether it goes ahead and shifts to the left. All right. So one common example of shifting the investment demand curve. Let's do A. Okay. Let's just suppose, for whatever reason, we'll talk more about this later, but suppose for whatever reason there's just an increase in confidence amongst firms where they expect the economy to be doing really well in the future, which means they expect the profitability of investments to increase in the future. So they expect profitability of investments to go up. Investments to increase. Okay? So for whatever reason, firms think, hey, it's going to become, investment projects are going to become more profitable in the future. And it's not investment in one particular industry like gasoline or green energy or anything like that. It's all investment projects in the economy have suddenly become more profitable for some reason. All right. Well, if that's the case, then simply ask yourself this question. Suppose you start off at point A, because remember, point A is going to be our reference point, and the real interest rate remains at R. And if that's a little abstract for you, say it stays at 5%, and let's say this is $1 trillion. There's $1 trillion worth of investment, or investment demanded, or funds demanded to finance investment projects. The real interest rate's at 5%. Now let's just say, now that's the cost to firms of going to the bank to borrowing to finance new investment projects. Now ask yourself this question. Suppose, for the sake of argument, firms think, you know what? The return on investments has just increased. If I build a factory, I'm now where I was, say, getting a 5% rate of return before. Now I think I'm going to get a 20% rate of return. And I only have to pay 5% of that in terms of interest. So what's that going to do to my incentive to the amount of investment I'm going to conduct? Yeah, obviously, this is going to make firms want to, purchase more capital goods, which means they're going to have to borrow to go ahead and do that. So if the expected profitability of investment increases, then this means firms are going to want to build, want more capital goods, more factories, more tools, all that, more capital goods. And if firms want more capital goods, then the quantity demand of loanable funds is going to increase. So this will increase the quantity demand of loanable funds, meaning the quantity demand of investment is going to increase. So if you're at point A initially, and this is the initial amount of investment firms want to go ahead and conduct, they're going to want to do more. How much more? I don't know. It's a qualitative result here, so I'll just go ahead and put this at I2. Call that 1.5 trillion if you need an actual number. All right. Now, if the real interest rate stays at 5%, and this is the new level of investment that firms want to conduct, then you would be at point B. All right. Now, is point B on the old investment demand curve? And the answer is obviously no. Anybody can look at that and say, gee, it's not on the old investment demand curve. Well, if it's not on the old investment demand curve, that means the investment demand curve must have shifted to the right, to I2. So I'll go ahead and draw it like that. Okay? So if you expect the profitability of investment to increase, then firms are going to want to go ahead and want more capital goods. That's going to increase the quantity demand of loanable funds, and the investment demand curve shifts right. Curve shifts right from I1 to I2. All right. All right, so that's the first example. It's a rightward shift in the investment demand curve. Now, I'm running out of space here, so I'm just going to go ahead and erase all this, and I'll do B as my second example. And we'll call it an increase in corporate income taxes. So let's do B. Increase in corporate income taxes. All right, and we won't worry about the details of it. Let's just say it's an increase in corporate income taxes across the board, so you're not taxing any one particular group of firms or anything like that. It's just a general increase in corporate income taxes. So if that's the case, if you increase corporate income taxes, that's going to decrease the after-tax profits from investment. So in some sense, it's the exact opposite of the case we had before. Before, we had firms suddenly became more optimistic, so they thought profits were going up. Now, because of the higher income taxes, the exact opposite's happening, profits are falling. So if we take A as our reference point again and say, all right, let's keep the real interest rate fixed at 5%, what's going to go ahead and happen? Well, if after-tax profits fall, then that means firms are going to find investment projects less profitable, obviously, which means there's less of an incentive to go ahead and do them, so they're going to go ahead and do less. Well, if you decrease after-tax profits, we can think that increases the quantity of investments that firms want. So it's going to decrease the quantity demand of loanable funds. How much? I don't know. If you start off at 1 trillion, maybe it goes all the way down to 0.5 trillion. just to pick a number. Which means if the real interest rate stays at 5% and the level of quantity demand of investment or quantity demand of loanable funds falls to 0.5 trillion, then you're going to be at a point like C. Obviously, C is not on the initial investment demand curve, so there must be some new investment demand curve that looks like this. Call it I3. So the investment demand curve must have shifted to the left, right? And I think from that you'll see the general principle. And the general principle is just basically this. The investment demand curve shows the relationship between two things, the quantity investment demand and the real interest rate, assuming everything else is held constant. And what's everything else from our perspective? That's expectations of profits. Okay? And when expected profits increase, the investment demand curve is going to go ahead and shift to the right. And when profits decrease, the investment demand curve is going to shift to the left. So no matter what example I might ask you in the future, you just keep that simple thought experiment in mind. You should be able to handle any example I throw at you. It's the investment demand curve shows the relationship between the real interest rate and the amount of investment, assuming the level of profits are held constant. If something happens, expectations about profits go up in the future for whatever reason, investment demand curve is going to shift to the right. But if for whatever reason expected profits fall in the future, the investment demand curve is going to go ahead and shift to the left. All right, we'll stop there, and then I'll pick it up and talk about the supply side next. It's kind of arbitrary, but I stopped it there because first of all, I wanted some water. And second, it might be better just to have smaller ones than larger ones. Oh, you did? Oh, okay. Well, then what do you think? Should I? All right. All right. So now I want to talk about the supply side of the loanable funds model, which is going to come from national savings. So if you remember back to the circular flow diagram, households are the ultimate source of loanable funds for the financial sector, which then decides who gets the loans, and it goes ahead and finances all the loans, such as the investment projects and new housing and new capital goods. So we're going to go ahead and say national savings is some function of the real interest rate. Why? Because the real interest rate, it's the cost of borrowing funds from the perspective of the borrower, but the real interest rate is the reward for savings from the perspective of the person supplying the loanable funds. Reward for savings. So right now, the interest rate on my Bank of America savings account is real low, 0.25% or something like that. When you take into account inflation to convert from a nominal to a real interest rate, I'm getting a negative return each year on my money that's in my savings account. Well, as that real interest rate goes up, so right now there's a disincentive for me to put money in my Bank of America savings account each year, right? But as the real interest rate increases from a negative number to 0 to say 1% to 5% to 10%, the reward for savings is actually going to go up. So the more money I put in my savings account, as the real interest rate goes up, the more money I'm going to have at the end of the year, which means I'm going to be able to buy even more stuff. So an increase in the real interest rate increases the reward for savings. So households are going to have an incentive to go ahead and increase the quantity supplied of savings or loanable funds and decrease consumption expenditures. So if you think of income as held constant, if the real interest rate goes up, then households are going to save more, which means by definition they're going to have to be consuming less, right? So in this case, so if that's all the backdrop, then we'll just go ahead and do the derivation. And we'll talk about things that shifted around. So here it's again going to be our diagram where I'm again going to put the real interest rate on the vertical axis, except this time I'm going to put savings on the horizontal axis. And just like investment, we're going to measure savings in dollars. So it's essentially the same vertical or horizontal axis for both. And again, I just need a reference point, so I'm just going to go ahead and say, hey, here's the first real interest rate. And let's suppose, for the sake of argument, at that real interest rate, oh, I don't know, let's say there's $500 billion worth of savings that households want to go ahead and do. And I'll go ahead and call that point A. Okay? And suppose for some reason, and I don't care why right now, again, I don't have a full model yet, so I can't give you an explanation for why the real interest rate goes up. Let's just say it does. So the real interest rate goes up to R2 for some reason. Well, what's going to happen to the amount of national savings? Well, if the real interest rate is a reward for savings, then the higher the interest rate, the greater the reward for savings, the more households are going to save. So the quantity supplied of loanable funds is actually going to end up rising. How much is it going to rise? I don't know. Let's just say it goes up to, I don't know, call it $1 trillion. Just to pick a number. Well, if the quantity of national savings goes up to $1 trillion, then that means point B is going to be right here. For us, 2 points are going to determine a line. So I'm just going to connect points A and B. And that's going to be my national savings curve, which is also going to be the supply of loanable funds. As real interest rates go up, the quantity supplied of loanable funds is going to increase. Why? Because households have a stronger incentive to delay consumption and save. So there's going to be more funds provided to the financial sector for them to go ahead and disperse to people who want to borrow for investment projects. All right. Again, we're going to want to talk about things that go ahead and shift the national savings curve around. So 2 is derivation. That means 3 is going to be shifts. Right? And again, there's going to be a whole host of things that potentially could shift the national savings curve around. I'm just going to talk about 1 or 2 so you can go ahead and get the flavor. But basically, it's going to boil down to this. If the event I described causes the amount of national savings to increase, at every given real interest rate, then the national savings curve is going to shift to the right. If the event I described is going to cause the quantity of supplied of national savings to fall at any given real interest rate, the whole national savings curve is going to shift to the left. So that's basically what it comes down to. Okay? So let's do shifts. And for this, I want to just go ahead and remind you, hey, national savings is income minus consumption minus government expenditures. And for simplicity right now, we can relax this assumption later on. Let's just go ahead and say the level of income is fixed, meaning the size of the economy is constant. Right? What you'll see later on is that's essentially saying we're at potential output and potential isn't changing. Or we're on something called the long-run aggregate supply curve. Right? Well, if this is the amount of national savings, then let me just ask this simple question. What happens if the government decides to go out and increase government expenditures? Say there's a war, so the government goes out, buys a whole bunch more tanks, more aircraft carriers, more bullets, hires more military personnel, things of that nature. Right? So if there's an increase in government expenditures. And we're holding everything else constant. All right? Well, if we're holding everything else constant, that basically means holding consumption expenditures constant. If you increase government expenditures, you hold consumption expenditures constant, and you're holding real GDP constant, then by definition, what's got to happen to the amount of national savings? It's got to fall. Decrease national savings. How much? I don't know. Okay? Well, let me actually, should be drawing this over here, so let me actually go ahead and do that right now. And say, here's our example. I need a national savings curve over that. I'm just going to go ahead and label S1. Right? I'm going to pick a real interest rate at random just so I can have a point of reference. Call it R. And go all the way across here. Call this point A. Down here, this is the amount of national savings. And we'll go ahead and call that 1 trillion. Just to have an actual number. And like before, we'll go ahead and call that 5%. All right. Now, if the government goes out and there's a war, or for whatever reason the government decides to go out and spend more, there's an increase in government expenditures, which if you keep consumption and real GDP constant, mathematically there's no way around it. The amount of government, or excuse me, the amount of national savings has to fall. By how much is it going to fall? I don't know. But it will decrease. So if this is the initial amount of quantity supplied of national savings, the new amount is going to be somewhere down here. Let's call it S2 equals, I don't know, call it $500 billion. Well, if now at 5% interest, there's $500 billion, households want to save $500 billion, the economy's at point B. Is point B on the old national savings curve? The answer is no, it's not. So what must have happened? The entire curve must have shifted to the left. Right? So if this happens, there's an increase in government expenditures, which is going to end up decreasing the quantity supplied of national savings. So this decreases the quantity supplied of loanable funds, i.e. decreases national savings. Well, that's going to end up shifts the national savings curve left from S1 to S2. So we'll go ahead and call that S2. All right. And just to go ahead, I think you get the general idea, but just to go ahead and say I was complete, let's go ahead and do B, and let's just talk about what would happen if suddenly households want to save more for whatever reason. So we'll do B. For whatever reason, households are just overcome with the desire to save. i.e., there's a decrease in household consumption expenditures. Well, remember, national savings is real GDP minus consumption minus government expenditures. We want to hold everything except consumption constant. So real GDP is going to be constant. Again, think of that as fixed at potential output. Now government expenditures are going to be constant. They're not changing. So if there's a decrease in consumption expenditures, mathematically, there's no way around it. If you keep income constant, consumption falls, and government expenditures are constant, the amount of national savings is going to have to go increase. So the decrease in consumption expenditures is actually going to increase the quantity supplied of loanable funds, i.e., increase national savings. How much? I don't really know. Let's just say if the real interest rate is fixed at 5%, that the amount of national savings goes up to $1.5 trillion. So that means you're going to be at a point like C. Point C obviously is not on the initial national savings curve, which means the national savings curve must have shifted to the left from S1 to S3. Therefore, national savings shifts right. Shifts right from S1 to S3. All right? And I think you get the general idea. Is the real interest rate, or excuse me, the national savings curve shows the relationship between two things. The real interest rate and the quantity supplied of national savings, holding everything else constant. And that everything else constant is basically going to be consumption and government expenditures, and also real GDP. When one of those three things changes, the entire curve is going to end up shifting. All right. So that's the national savings curve. So we've got a supply curve, we've got a demand curve. So the next thing to do is just go ahead and take these two curves together and go ahead and show you and explain to you equilibrium. So if that was B in our outline, then equilibrium must be C. So I'll just go ahead and erase all this. And call it C, equilibrium. All right. So now in equilibrium, it's going to be just like a supply and demand diagram that you've had from microeconomics. We're going to go ahead and put the price on the vertical axis. That's actually not even remotely close to horizontal. Let's see, that'll be a little bit better. Here's your real interest rate. And you just have to get used to thinking of the real interest rate as not only the reward for savings when you're talking about the national savings curve, but it's also the cost of borrowing. So it's essentially the price of investment. All right, so we're going to have some nice upward sloping national savings curve. We're going to have some nice downward sloping investment demand curve. And notice I'm just using S for savings and I for investment now. I'm not writing out supply of loanable funds or demand for loanable funds. Equilibrium is going to occur at point A, where you've got the real interest rate. And the interesting thing, or what makes point A an equilibrium, as we'll point out, is everyone essentially is going to be happy, or more specifically, nobody, households and banks or the financial industry will have no incentive to change the real interest rate. So if you're ever not at point A, I'm going to claim there's a built-in tendency for the market to move back to point A. But when you're at point A, there's going to be no incentive for either households or I should say borrowers or lenders to alter their behavior. And the reason for that is because the quantity supplied of loanable funds, S, is going to be exactly equal to the quantity demand of loanable funds, the level of investment. To see that, if this is the real interest rate, how do I find quantity supplied? I go from the real interest rate to my supply curve, which happens to be at point A, and down, and call that S. Okay? And if I need to find the quantity demand of loanable funds, I go from the real interest rate to my demand curve, which just happens to be at point A, and down, and I'm going to find I, and I'm going to find those two are equal. So when you're in equilibrium, and I'm going to put a little star on this real interest rate to let you know it's the equilibrium interest rate, and I'll put a little star on this level of investment to let you know that this is the equilibrium level of investment. And I'll put a little star on this level of savings to let you know it's the equilibrium level of savings. And this is all going to be number one under equilibrium. Okay? So what makes point A equilibrium is the quantity supplied of loanable funds is exactly equal to the quantity demand of loanable funds. Okay? It's the supply and demand curves intersect at that point, but the key point is there's going to be you're going to have an equilibrium because quantity demand equals quantity supplied. Okay? Now, let's suppose you're not there. Okay? I'm going to claim there's a built-in tendency for markets to push you back to equilibrium if you're ever not there. So let's just say, for the sake of argument, and I don't care why, let's just say for some reason you're at a real interest rate like R1. Okay? Suppose the real interest rate is less than the equilibrium real interest rate. I just want to talk about how the market's going to move back towards equilibrium. Well, if the real interest rate's below the equilibrium real interest rate, the first thing you have to do is figure out, first of all, it should be obvious you're not in equilibrium. So if you're not in equilibrium, if you think back to microeconomics, that means there's either going to be a shortage or a surplus. And to figure out if there's a shortage or surplus, you always look to two things: quantity demanded and quantity supplied. Right? So if the real interest rate is low, like R1, and you want to find quantity supplied, you go from this interest rate all the way over to the supply curve, which is our supply of national savings, and down to the horizontal axis, so the real interest rate all the way over. I won't bother labeling this point B or anything, and down, and I'll call that S1. That's the quantity supplied of loanable funds. And if I want to find how much households and firms want to borrow at this low real interest rate, I simply go from the real interest rate over to the demand for loanable curve for loanable funds, which is the investment demand curve, and down, and call that I1. Okay? So suppose the real interest rate is less than the equilibrium real interest rate, then you're going to be in a situation where national savings, the quantity supplied of national savings, is less than the quantity demand of national savings, i.e., a shortage exists. Okay? And if it helps, we'll say this is 1% and this is 5%. Some people like to have make it a little less abstract, so I'll go ahead and call this low interest rate 1% and the equilibrium 5%. Nothing special about those values, it's just to have a value. All right, well, think about what happens if there's a shortage in the market. Okay, what does that mean? That means that there are a bunch of households and firms that would like to borrow at 1% interest, but they can't. Why? Because not enough people want to save at a 1% interest rate. So the amount of savings that's occurring when the interest rate is 1% is a lot less than the amount that people want to borrow when the interest rate is 1%. Okay? So how are markets going to respond? Well, if you think about it, if you think about it from the perspective of someone who's borrowing to buy a house, if you can't borrow, if you would love to buy a new house when the interest rate is 1%, and you can't and you can't get a loan when the interest rate's 1%, what can you do? Well, banks are greedy profit-maximizing firms, like all other firms. And from that perspective, if banks really are just greedy profit-maximizing firms, the one thing that you can do to convince, say, Bank of America to loan to you rather than somebody else is say, well, if everyone else is paying 1% interest, I'll go ahead and pay 1.5% interest. Right? Because remember, how do banks make their money? Well, they borrow money at low interest rates, and then they go ahead and loan it out at a higher interest rate. And if you signal to the bank that you're willing to pay a higher interest rate, then that means that you're more likely to get the loan than somebody who's only willing to pay 1% interest. And the same thing's true for firms. Right? There are some firms out there who would love to borrow because they've got these wonderful investment projects, and when the interest rate is 1%, they want to do a heck of a lot of borrowing to finance these investment projects, but not enough people are willing to supply loanable funds at the low interest rate. Well, if you're one of those firms who wants to borrow but can't, how do you convince banks to loan to you rather than someone else? You offer to pay a higher interest rate. Okay. Now remember, borrowers don't offer to pay a higher interest rate just to be nice because they like banks like Bank of America and Wells Fargo, et cetera. They do it because they have to. If they want the loan, they've got to pay more. Okay. So what ends up happening here, there's a shortage exists. Therefore, borrowers have an incentive to bid up the real interest rate. To bid up the real interest rate. So I know the real interest rate is going to start rising because some borrowers are going to say, you know what, you won't loan to me at 1%, then I'll pay 1.5 or 2 or 2.5 or whatever it is. But when the real interest rate goes up, that's going to cause both quantity demand and quantity supply to adjust. So when there's a decrease or an increase in the real interest rate, then that's going to have an effect on the demand side. So if you think about it, the real interest rate starts rising from 1 to 1.5 to 2 to 2.5. As the real interest rate rises, some people are going to say, you know what, I can't afford to buy a house when the interest rate's 1.5%. So they drop out of the market. In other words, the quantity demand of loanable funds decreases. Other firms are going to say, you know what, this investment project I had, I loved it when I could borrow at 1%, but when I have to borrow at 1.5 or 2% or 2.5, it's no longer profitable. I'm not going to go ahead and do it. So what they're going to end up doing is the quantity demand of loanable funds is going to end up decreasing, meaning you're going to start moving up along your investment demand curve like this. Right? And by itself, as quantity demand starts decreasing, that's going to make the shortage smaller and smaller. Likewise, on the supply side, as the real interest rate is increasing from 1% to 1.5 to 2%, that acts as a signal to households that says, hey, you know what, the reward for savings is now higher than it was before, do more of it. So as the real interest rate goes up, households have less of an incentive to consume today and more of an incentive to save, so they start saving more. Well, when households start saving more, the quantity supplied of loanable funds starts increasing, and you start moving up along the national savings curve. Okay? And that by itself will tend to eliminate the shortage as households start saving more. And as long as the real interest rate's below the equilibrium, there's going to be a shortage, which means there's going to be some firms out there who have an incentive, or some borrowers out there who have an incentive to bid up the real interest rate. And as long as there's some households out there that have an incentive to bid up the real interest rate, or some borrowers out there who have an incentive to bid up the real interest rate, that means quantity demand of an investment is going to fall, and quantity supplied of loanable funds is going to continue to increase. Which means, I should go ahead and write it up here. You increase the real interest rate, that's going to decrease quantity demand of loanable funds. I.e., decrease investment. And it's also going to increase the quantity supply of loanable funds. I.e., increase national savings, or the quantity supplied of national savings. Okay? And so this bidding up of the real interest rate is only going to stop when you reach an interest rate of 5%, because at that point, the amount of national savings is going to exactly equal the amount that people want to borrow. So there's going to be no potential borrower out there who's going to say, hey, I'm willing to pay more, because every borrower who wants a loan at an interest rate of 5% can go ahead and find one. Okay? Now, I could tell exactly the same story, and I guess I should say stop when the real interest rate equals the equilibrium real interest rate, because at that point, the quantity supplied of loanable funds is going to be exactly equal to the quantity demand of loanable funds. And the important point is no borrowers there is no borrower out there who has an incentive to go ahead and bid up the interest rate further once everybody who wants a loan can get a loan. All right. So that's equilibrium. And so, like I said, economists care about equilibrium not necessarily because we think the economy is always in equilibrium. It's because if you're ever not at equilibrium, there's a built-in tendency for the economy to move there. So if we ever found ourselves in a situation where real interest rate was below equilibrium, the economy would be moving towards equilibrium. Okay, I haven't said anything about how quickly that happens, and we'll worry about those issues later. But if you're in equilibrium, you tend to stay there, and if you're ever not in equilibrium, you tend to move there. And if I wanted to, I could go ahead and tell exactly the same story, except when the real interest rate starts off at above equilibrium. The difference would be, if I call it R2, I won't do it at the board. You just end up flipping all these inequalities. The real interest rate's greater than equilibrium, so the quantity supplied of loanable funds is going to be greater than the quantity demand of loanable funds, so it won't be a shortage. It'll be a surplus. And borrowers will no longer have an incentive to bid up the real interest rate. It'll be lenders have an incentive to bid down the real interest rate. Right? So there'll be a decrease in the real interest rate, an increase in quantity demand, and a decrease in quantity supplied. So you just reverse all the arrows until you reach equilibrium. And it'd be good practice for you to go ahead and walk yourself through that story to make sure you can tell it at the level of detail that we just told the story of what happens when there's a shortage. Okay, stop there.